Welcome everybody to the iWiz Power webinar series. Good morning, good afternoon, and good evening, since we have people across the globe. And going by our philosophy of zero false positive, we will be keeping our webinar short, precise, and absolutely to the point. We value and respect your time. The first 3 minutes I'll spend on some original statistical insights gathered from the results of 5,000 plus application security tests which has been conducted at iWiz. And the next 15 minutes I'll spend on 80-20 rule in application security management. And before we do that, let me quickly brief you about iWiz. iWiz is a pioneer in cloud-based application penetration testing. Probably we are the first in the world to take penetration testing or ethical hacking to the cloud. Unlike the other products in the market, we guarantee zero false positive. We conduct business logic testing with 100% WAS class coverage. iWiz is funded by IDG Ventures. We discovered 30 plus zero-day vulnerabilities in products like Microsoft BitLocker, McAfee SafeBoot, Intel, HP, Lenovo, Symantec, and several others. We got several recognitions from organizations like Red Herring, University of California, Berkeley, US Navy, Homeland Security, etc. More than 300 customers use iWiz, and Gartner also featured iWiz in 2 of their hype cycles, dynamic application security testing and application security as a service. So as a background, I'll quickly discuss with you all on the application security statistics of 2012. We gathered the real application security test results of 5,000 plus application tests that we conducted at iWiz for more than 300 customers. We'll not discuss much over here. Some of the interesting findings were like 99% of the application tested had at least one vulnerability, and 82% of the web applications had at least one high and critical vulnerability. We observed very low correlation between the organizations with and without compliance. And that says that they had the same level of vulnerabilities whether they had any compliance or certification or not. The average number of vulnerabilities per website that we observed was 35. Here's some more breakup based on the size. For the large websites, we saw 78 as an average number of vulnerabilities, small websites 26, and medium as 35. These are the top 5 application security flaws which we noticed. Cross-site scripting occurring in 65% of the cases, then information leakage, content spoofing, insufficient authorization, and cross-site request forgery. These are the 5 most common business logic flaws which we observed. I wanted to quickly touch upon the business logic flaws. These are probably the most overlooked vulnerabilities with the highest impact. So these vulnerabilities are not due to insecure coding, but due to wrong design of business logic. For example, if we can use the same coupon multiple times during the same transaction, weak password recovery, or price manipulation during transaction, insufficient server-side validation, etc. So back to our original topic of using 80-20 rule in application security management. I believe all of you know about this, that 80% of the effects actually come from 20% of the causes. However, it's not very easy to practice. We know it, but it's not very easy to practice. It's very difficult to say no. So some examples are like 80% of our profits can come from 20% of our customers, or 20% of the rules detect 80% of the spams. And by the way, the opposite of 80-20 rule is also true, and that's known as long tail, but I'm not going to discuss long tail today. So these are the top 7 mistakes which we noticed when we worked with these 300 plus organizations, or even while interaction with other organizations who are not our customers. The hash one mistake is probably trying to achieve security at a lower cost. Cheap security is equal to no security. It's something like having a cheap lock is equivalent to having no lock. The other thing is lack of prioritization and having the proper all-round investment. I have seen so many cases where it's something like people have a very strong iron door, but the walls are thatched walls. So you can't break the iron door, but you can just break through the walls. So not being able to say no and not being able to prioritize the right elements is another top mistake. Then the security initiative not being introduced early on, that is in the design phase or in the conception phase, is another. Lack of proper application security organization. Application security is relatively new. Defining the right kind of roles, KRAs and KPI is something which is missing. Trying too many things at the same time, or trying to do everything in-house. This is a big mistake. Probably the right solution is in the right balance between doing things by yourself and outsourcing. Then the other is not choosing the right vendor or the product. And the last but not the least, thinking that secure seal is equal to real security. There are so many security seals out there in the market, and all of them actually says you can hack me. The secure seal are the ones which are the cheapest level of security that you can get, and those are not by any means real security. So I'll discuss on the top 5 steps that you need to take in terms of this 80-20 rule or prioritization. And these steps you can take in this order in which it is mentioned here. The first step is identification and classification of all the applications that you have. I'll get into the details because there's a lot of interesting stuff in the details. The second thing is conducting tests on a regular basis. The number 3, implementing an efficient patching process. Number 4, implementing secure SDLC, and number 5, implementing a web application firewall for business critical apps. So the first step, identify and classify. So this is something which we have observed in the industry, especially with larger organizations. 90% of the organizations do not know how many applications they have. They don't know who owns which application. They don't know which applications are business critical, which are not. So the first step is identify your apps. You can use automated application discovery tools, or you can do it manually by asking all the departments. And of course, the automated one is probably more reliable. The next step is the classification of your applications, and we will do simple classification. One bucket is business critical. So these are the applications which can cause revenue loss, reputation loss, or can have legal implications, or it can make you lose your job. So those are the business critical applications. The other bucket is non-business critical. So everything which are not business critical, put it in non-business critical, just to keep it simple. The next step is about creating a regular security testing strategy. And please notice the word regular. It's more important to do regular testing than doing once in a year very in-depth testing. So we'll discuss on the security testing strategy. So before I get into that, we just discussed on classification of your applications, 2 classes or 2 buckets. And the next is to create 2 types of security testing. One type is automated application security testing, and the other type is comprehensive penetration testing, where we use both automated and manual security testing. So these are the 2 types of testing which we will apply over here. And the strategy for the business critical application should be that we conduct comprehensive penetration testing once during every major release, or at least once a quarter. Now this is very important. You need to get the budget for this. This should be irrespective of your budget. And if you have money left, you can do some automated testing once a month. The strategy for the non-business critical applications should be 1 to 4 automated tests per year. Based on your budget, you can decide the kind of frequency. The second is conducting one comprehensive test per year, and if that kind of suits your budget. So for non-business critical app, you can actually be flexible with your budget, but for the business critical apps, it's very critical that you have a flexible budget. Now, this is a common question which I keep on hearing: should I choose dynamic application security testing, or should I choose static application security testing? So in DAST, you don't need the code, whereas in SAST, you need the code or the binary. So which one should I choose, DAST or SAST? So we believe that the first step should be dynamic testing. This is absolutely low-hanging fruit. This is how a hacker out there on the internet is going to try to break into your application. So this is the first thing which you can't avoid. And it is easy to adopt, it's less expensive, and it's more mature in terms of adoption in the market. And step 2 is conducting DAST and SAST combined. So DAST and SAST combined, or IAST, which is interactive application security testing, is the future. There are lots of advantages like lower false negative, better coverage, but it of course comes with higher cost and higher overhead. And the other question is like, should I choose tools, or should I go to consultants, or should I use some cloud solution? So if you are using tools, whether it's a lower cost tool or it's one of the best tools in the market, each of these tools will produce false positive. And these tools cannot conduct the business logic testing. So you need to have in-house team to remove false positive and conduct business logic testing. The consultants, they give you good quality results. However, they are costly and they cannot scale. You can't use consultants to conduct thousands of tests in a year. The third option is cloud, and you have two types of cloud. One is just the typical licenses or the typical automated tools on the cloud, just on demand. And the other cloud option, which is there, combines automated testing with manual intervention or manual validation. So we kept the on-demand tools in the first bucket itself. So the last bucket, which is the cloud with human intervention, the advantages are it's good quality, scalable. However, the vulnerability data is going to be on cloud, and you need to keep your application accessible via cloud. So which option should you choose? You can choose cloud that with human augmentation, and that probably is the most optimal solution for 80% of the cases. There's no license cost, no people cost, is scalable, it's more cost effective. However, you can use automated tools or on-demand tools if you can hire and retain an application security testing team. And let me tell you, less than 1% organizations can do that. It's very difficult to get the right kind of guys and more difficult to retain them. However, if your business demands that you can't, you have to do things in-house, you can't let the data go out, then you have no option. You've got to build your in-house team with automated tools. Or if you are kind of building advanced secure SDLC, having tools in-house could be meaningful. The third option is consultants. If you have a non-standard application which is highly complex, you don't have in-house team, then consultants are the way to go. They're more costly, however, they are higher quality. So these are some questions. These are the 9 questions which you can ask your consultant. So one thing we need to keep in our mind while getting engaged with a consultant is that it's the person who matters the most. It's not the organization, but it's the individual. So you need to know who is the individual who is going to conduct the test. How many application security tests did he or she conduct before? What are the contributions of the tester in the security research, like vulnerability discovery, research papers, tools, etc. What's the methodology of the security testing? And this is very critical. How does he ensure coverage? Does he have a checklist? Can he share that or show that to you? This is something which is very important. We cannot let the security testing quality be dependent on the state of the mind of the security tester. Then the other question, how will he conduct business logic testing? You need to know how does that person do that. Where will he store the data? How will the data be kept secure? Because keeping data in the laptop is not really the most secure thing. How does it protect your critical information? Can he test during non-business hours if that's a need for your organization? Can he meet up to your scalability requirements? Like if you have hundreds of applications, can you get all of those tested by them? So these are the top 9 questions. But one thing which is very important is you need to ask yourself, can you conduct adequate number of tests as per what we discussed just a while before in terms of the testing strategy within your current budget using consultants? So this is a very critical question you need to ask, because not conducting tests on a regular basis is not a good way to move. Conducting tests just once in a year is not the right thing. You need to conduct regular testing. So that right balance is very important. These are the top 5 metrics to benchmark a tool. What are the things you need to look into? Those are like, what's the rate of false positive? How many classes of vulnerability does it cover? Which are the classes it doesn't cover? How good is the coverage of the crawler? Is there any benchmark against the other tools? How many scans can run in parallel? And another very important thing is like, how does it benchmark against the other tools in terms of both false positives as well as false negatives? So you can benchmark the same tool against 3 or 4 other tools or a consultant to check out how good it is. Then the third thing, after the classification and regular testing, the third thing is efficient remediation process. It's of no use if we can't fix the vulnerabilities. So you need to create awareness among the engineering team members. This is the first step. In most of the organizations, the right kind of awareness is not there in the engineering team. You need to create an effective communication channel between the security testing and the engineering team. You need to have a spokesperson, have the internal wiki, have a nice, proper system and process set up. And then you need to create effective process to raise tickets, manage and monitor them, and conduct revalidation tests once the vulnerabilities are closed. The average vulnerability closing time should be a part of the KPI of the internal team or the SLA for the outsourced development organizations. Step 4 should be adoption of secure SDLC. So these are the few top application security principles which one needs to keep in mind. Going by the 80-20 principles, if you can kind of keep these few in mind, it'll help you to achieve at least 60 to 70% of security. For the rest of it, you can get into the details. I provided the link at the end. So back to the top few security principles you need to keep in mind are validation of the input data, encoding of the output data. These two are so critical. Implementing principle of least privilege, fail securely by default. Then for the sensitive transactions, you need to use anti-automation or challenge response or re-authentication, like what LinkedIn does in case of re-authentication. I don't mean to say they have good security though. Implementing secure session management, like issue or reissuing new session cookie for each login, automatic session expiration, etc. Session management is a very critical part. Implementing strong known cryptographic storage. You don't need to invent a new one, just use a good known strong cryptographic algorithm. And the top steps towards secure SDLC. The phase 1 is to create a minimal coding, designing, or the minimum kind of secure SDLC. It's a minimal secure SDLC which you can create and then implement it and monitor it and measure it for some time. And in the phase 2, you can go full blast. So the reason why I am a big advocate of doing this in 2 steps is people are resistant towards change, and there is adoption overhead. There is a learning cycle. You will make mistakes in the first go. So use the prototype model or the spiral model. Go for a smaller implementation and then go for the bigger implementation. So phase 2 is our goal, but phase 1 is a step towards achieving the goal. So many in our organization, for a different kind of scenario, when we wanted to implement a big process, we failed, and then we decided to break it down. The last is the web application firewall. So There are lots of advantages of web application firewall. It protects the application from the known simplistic and the common flaws. So there's a basic level of security. You can actually have some level of protection even before the flaws are patched, because it takes some time to patch every flaw. But there are, of course, cons as well, that it does not protect against the advanced and new attacks or the business logic flaws. It can reduce the application performance. It may block legitimate requests. And of course, using a WAF is not by any means substitute for secure development practices. You've got to fix the flaws. So a quick recap of 80-20 rule, the top 5 steps which we discussed: identification and classification of all your application based on business criticality, creating a regular testing strategy. We discussed on like 2 types of tests being applied on the 2 buckets of application, implementing an efficient patching process, implementing secure SDLC, and implementing a WAF. So at least if you can implement the top 3 or 4 things, it will not take a huge overhead, but can give you considerable amount of security. And these are the top few free online resources which you might consult. These are all from OWASP. We found this to be the best source. You can just refer to these and get into more details. So thanks a lot, everybody, for joining the Power webinar. We try to keep it short and precise, and we hope this was helpful to all of you. If any of you have any question, please type it in, and we can just try to address those. So somebody asked me about the different kind of tools which are there, which somebody could use for testing, and the different types of the different firewalls which I might suggest. So what I will do is I will separately share the list of companies which got good firewall and as well as application security testing. And I got another question on how to access the presentation. We will share the link of the slides with all of you. We'll send it to you over an email. It will be hosted on our site. I got another question on false positive and false negative. So the question is it are false negative worse or false positive? Which is worse? So this is a very interesting question. It's very difficult to compare which is worse than the other. False positive means higher cost. So what it means is that you got to remove those false positive by employing humans. So that means that's going to cost you money. Whereas false negative means the vulnerabilities which are missed out, it could be costly in a different way. It could be costly in terms of creation of a big vulnerability in your application, which could lead to compromise. So both of these are costly, but in different ways. One is a big risk, the other is not. So the idea is to minimize both. So the cloud solutions which are human augmented could be a good balance. When you buy a tool, you should look into which tool has got lower false positive, so that kind of reduces your overhead. I hope that answers your question. So thanks a lot, everybody. I hope you all enjoyed the webinar. We will have more webinar in future, which will be short and precise, and hopefully that will help. Okay, so this is another question before I end. Like, what strategy would you use to make direction aware of the necessity to minimize false negatives? Sometimes management is more worried for false positives. Yeah. So let me discuss the first part of your question: how to minimize false negatives. So at IVIS, a few things which we do, I can tell you. Um, so one is we use multiple scanners. We have one product, which is our own product, which we call, which is our in-house product, which we developed, and we got certain other products, 3 more commercial tools which we use along with our in-house tool. So by using multiple tools, we reduce false negatives. The second approach which we take is we have built something called the workflow automation engine. So you can have a replacement of workflow automation engine in terms of a simple checklist, where you can have a list of all the business logic vulnerabilities, all those classes of vulnerabilities which are missed out by tools, have a list of those, and during every single test you actually go through that. So in short, these are the 2 approaches. One is use multiple scanners, and the second is have a strong process, and you can implement it in many different ways, where you have this good checklist of all the vulnerabilities that you need to test manually. So that's how you can deal with false negatives. And you mentioned that sometimes management is more worried about false positive. Yes, and that's true, because false positive means more immediate cash outflow. Since you have to remove those, you have to have higher manpower. So that means more immediate cash outgo. However, false negative opens the door for a lot bigger risk, which could be something very critical in future. So the only way probably you can handle this with your management is by showing that what could be the future risk if we miss out the false negatives. I hope that answers your question. Thanks a lot. So thank you, everybody, and look forward to your participation again in future. Thanks a lot.